This webinar is the third one in a series of webinars that were created in order to help chemistry students write an IMOD paper. As such, this session focuses on the results section of the journal article. The results section makes use of both text and graphics to highlight the essential findings of a study and to tell the story of scientific discovery. So I will not just focus on writing the text. I will share with you some information on formatting graphics, tables and figures, among other things. I use the term graphics to refer to figures, tables and schemes. Figures and tables are used to display, clarify and summarize results, helping readers comprehend data more quickly, and schemes are used to illustrate mechanisms. By the end of this webinar, you should be able to do the following: distinguish between the description and interpretation of data, organize and present your results in a clear manner, refer appropriately to a figure or graph in the text, use appropriate grammar, tense, voice and word choice, and prepare a properly formatted figure and table. The purpose of a results section, the third section in the standard IMOD format, is to present the most essential data collected during a research project. A well-written results section guides the reader's attention back and forth between the text and the graphics, while highlighting important figures of the data and telling the story of scientific discovery. Yet, here's a tricky part. Long pages of data are condensed into only a few pages when you publish. Hence, only the essential threads of the story are included in the results section. The results section often provides answers to the questions posed in the introduction. It presents and summarizes the only key data and provides graphics to illustrate condensed information regarding trends, measurements, and mechanisms. You will often read that there is a relevant degree of data analysis in the results section and at times interpretation of data. Yet, this is not always the case. It depends on the journal author guidelines again, as I have explained in previous videos. In many journal articles, the results section is actually a combined results and discussion section. Combined and integrated results and discussion sections are preferred by many scientists who want to present and discuss results in an unbroken chain of thought. The combination is often more concise because less time is spent reminding the reader which results are being discussed. Combined R&D sections are not all alike, they're not all the same. Rather, they fall on a continuum with fully separated R&D sections at one end and fully integrated R&D sections at the other end. So all in all, we get to have these three patterns emerging: the blocked R&D, the iterative R&D, and the integrated R&D. In the blocked R&D pattern, a single block of results is followed by a single block of discussion. And for example, for a set of 3 results, the pattern should be results 1, results 2, results 3, and then discussion 1, discussion 2, discussion 3. In essence, the blocked R&D pattern is identical to that of fully separate sections, but that merged under a single results and discussion heading. All these questions are a good guide for an integrated R&D section. With the integrated R&D pattern, results are presented and discussed together, often in the same paragraph or even the same sentence. Description and interpretation go hand in hand. The text is organized in a way that best conveys the story of scientific discovery with no obvious delineation, separation between results and discussion. This pattern is less common, but well done, but when it's done well, it can be very effective. Look at the questions and identify one that is mainly used in a blocked results section. You can pause the video now. That's right. It is only the third question that can be included in a blocked results section. In this video, we will mostly focus on blocked results section, focusing. So first, we're only going to be looking at the third section, which is usually demonstrated in such patterns. So in the results section, the results section entails storytelling without repetition. It is not simply a technical description of raw data or procedures, and it should never simply be a collection of numbers and tables. It's a narrative that explains the progress of research that eventually leads to the final results. For example, if you used HPLC to analyze the components of some extracts, the specific solvent conditions should not be elaborated. Instead, the results of the HPLC should be described. As a writer, you must learn to distinguish between description and interpretation, especially if you write a combined results and dissection. The following sentences can help you to clarify the difference. Have a look at these sentences. In a blocked results section, writers should be able to present data in an objective manner without providing explanations or interpretation. An objective description of results allows readers to examine the data unbiased by interpretation so that results can be viewed as a glimpse of truth. Having said that, words such as truth and prove seldom appear in scientific writing. In a computer-based analysis of 180 journal articles, prove was found only twice and truth never occurred. As I have mentioned already a few times before class, proof is a mathematical term, not a favorite chemistry term. Hedging words are used instead, and these words may be found in the second example, like maybe, in the second sentence of this slide. Another example is when instead of data and instead of prove, we say data suggest. Or when we write results often offer evidence instead of writing proof. So, coming back to the answer of this task, in the above sentences, it is clear that the spiked ethanol solution being exposed for different lengths of time at 50 degrees Celsius presumably conveys a truth or a fact that will not change. Thus, the statement is descriptive. However, the second sentence, it says that the higher coefficient of variation may not necessarily be due to the low levels of aldehydes, so the statement is interpretive. Let's have a look at another task here. At this point, you need to identify a sentence with a description and a sentence with an interpretation in the excerpts A and B. highlight a description with a yellow marker, and an interpretation with an orange marker. At this point, we can have another creative task where we can actually rewrite the following sentences so that they are more descriptive than interpretive. Let's take some time to do this task. You don't have to change all the sentences, you can just change one of those. You can pause the video now. Now it is really important to start noticing the key functions in the results section. To help guide your observations, I'm going to ask you some questions I want you to answer before I provide the answers. So let's do this. When or where is the figure or table mentioned for the first time? Are they just mentioned to help the reader locate them, or do they supplement another sentence about results? Did the author state or interpret the data presented in this section? Do graphics and prose, the text, enhance each other? Have a think. You can pause the video now before I give you the answers. As you have already noticed, the reader is briefly reminded how a particular set of results was obtained, and very, very quickly is referred to a graphic, a table or a figure that displays those results. This is often done in the first or second sentence of the results section. After the graphic has been introduced or located, as we say, then the writers tell the story of scientific discovery and as such identify important findings or highlight major trends. There is no interpretation and there is little repetition, explanation or analysis. The graphics reinforce the prose, the writing in the results section. Remember to refer to graphics before actually guiding readers through the results in the text. And avoid dangling graphics, that is, graphics that are included in a paper but never mentioned in the text. So the story is told using both text and graphics, typically tables and figures. Most authors determine the order of the graphics first. Table 1, figure 2, table 2, etc., as well as the order of the data within each graphic, entry 1, entry 2, etc., and then they write the text, the prose, to complement the graphics. Ultimately, the graphics and prose should work together, reinforcing but not duplicating one another. The reader's attention should naturally be shifted back and forth between the two. That said, I need to point out that graphics are not required in all instances, and occasionally an article will be published with no figures or tables. In fact, graphics should only be included if there is sufficient data and if graphics make the data more accessible to the readers. So avoid the temptation to plot all your data. Instead, plot only representative data, the data that needs to be illustrated, that needs to illustrate important trends in your study. I want you to start noticing more functions in the excerpts that you have in front of you, and answer these questions. Are the results described in chronological order? Are there any unexpected data? Where are they presented? You can pause the video now. Results may appear to be represented in chronological order, but usually they're not. Actual chronological order is often quite messy because of false starts, dead ends, and wrong turns. True chronological order only confuses the reader. Instead, effective writers use hindsight to intentionally rearrange their results in a logical sequence of events. So, chronological order is not the norm, although it can be used successfully. Broad to narrow approach involves many variable results not being shown at first before others, and only those that advance the story can be shown. If you read the guides for self-study, you will see that they say to select the data that you plan to present in a figure or table, then include at least one figure and table in your paper, check to be sure that you have enough data, organize the information in logical sequence, and then follow the same sequence as you write the text that accompanies the graphic. Regarding the next question, are there any unexpected data? Where are they presented? Yes. Usually scientists first refer to the expected data and then also refer to unexpected data. A favorite expression they use in the beginning of a sentence tends to be not unexpectedly, we found that, or it was found that. It's time now for another task. Based on your observations from reading the experts and my input so far, make a skeleton that delineates the structure of the results section before you move on to the next slide. You need to pause the video here. As you can see, this is the structure of results section in most examples. Authors usually set the stage. They refer readers to a graphic. Then they tell the story by identifying key findings, describing trends, and highlight unexpected results, if any, at the end of the results section. But now let's have a look at another step. Let's have a look at step 1, as you can see here. Step 1.2. Can you identify the sentences in one of the excerpts that serve this function? You can pause the video here. In step 1, we tend to locate the graphics first. In this way, the reader has the opportunity to read the data before reading the text, as shown in figure 1. This is the most common phrase in papers. Note that in both excerpt A and B, the reference to the graphic, table or figure comes before guiding the reader through the graphic. In this way, the reader has the opportunity to view the data before reading the associated prose. Often, the graphic is introduced in parentheses. Note too that the use of subheadings in these excerpts can be a particularly effective way to direct the reader's attention to each set of results. After the stage is set, you are ready to tell the story behind the data. The story is told using both text and graphics, as we said. We need to determine the order of tables and figures first and then write the prose. Ultimately, the graphics will reinforce the prose, but they won't duplicate it. Having said that, please remember that graphics should only be included if there is sufficient data and if the graphics make the data accessible. I think I've already mentioned that. Now, let's have a look at another task. I want you to consider the two excerpts provided and identify the variables featuring in the results section. chemists often use a broad to narrow approach, and they limit the number of variables to those that advance their story. Presented expected results first. The first set of results presents broad data from a protox assay in your excerpts, a test that looks at all 13 possible stress promoters that can be induced in bacteria by chromium compounds under investigation. According to this test, both chromium chloride and chlorine nitrate induce similar stress promoters, producing profiles indicative of DNA damage in excerpt C. Alternatively, chromium oxalate induced very few stress promoters, and its profile was not indicative of DNA damage. As the authors state in excerpt A, interestingly, none of the 13 stress promoters were induced when bacteria were treated with chromium oxalate. The authors use the word interestingly to call the reader's attention to the observation that chromium oxalate is somehow different than chromium chloride and chromium nitrate. As you will see, this statement foreshadows results that are presented later on in this excerpt. Another point that illustrates a broad to narrow approach is that the authors later on reported only for chromium chloride, not for chromium oxalate or chromium nitrate, which they omitted. At the start of a research project, there are typically many variables. However, as knowledge is gained, some of these variables can be eliminated. In this case, chromium oxalate was eliminated because it does not enter the cell. Chromium nitrate was eliminated because it mimics chromium chloride. Authors risk diluting relevant results by including extraneous data that fail to advance their story. To sum up, the authors initially reported multiple variables, 3 chromium compounds, but ended with a narrower focus, 1 chromium compound. In each case, the readers benefited from the researcher's hindsight. Learning to tell your story of scientific discovery in retrospect by reorganizing your data and highlighting only the most illustrative pieces is an essential skill in effective writing. Now let's look at the table and write a sentence reporting measurements in chromium oxalate, especially those that refer to measurements like 0. You can pause the video now. Measured concentrations should not be reported as 0, even if the substance is not detected. A more sensitive instrument, one with a lower detection limit, might be able to detect it. In other words, even if you don't see the substance, it might be there. First, we consider the concept of 0 in measured concentrations. Recall that no chromium oxalate was detected in the cells. However, the authors do not report this with a 0. Rather, they use the phrase below the detection point or limit, or the less than symbol, giving quantitative values there, which puts an upper limit on the amount of chromium oxalate present. Novice writers might suggest that no chromium was present in the text, but this is incorrect. Or they might use a 0 in the table. Such uses of 0, however, are incorrect because for measured concentration, 0 varies with the sensitivity of the detective instrument. For example, on one instrument, 0 will be less than 1 part per million. On a more sensitive instrument, 0 will be less than 1 part per billion. Instead of reporting 0, authors report that the measurement was below the detection limit, as we say, or cannot be detected, or we can say that we can give the numbers, as you can see here in the table. Now let's focus on graphics. Before we do that, I want you to read carefully excerpt C. In this article, the authors propose a way to synthesize aromatic tetrazoles from nitriles in water using only sodium azide and a zinc salt. Water, despite its obvious advantages, such as being safe and inexpensive, it rarely succeeds as a solvent in organic synthesis. Thus, a synthesis that uses water successfully is an important scientific accomplishment. I will begin the analysis of this excerpt after you examine how it uses compound labels. So let's do a task first. Read the excerpts and find one example of compound label and highlight it with a green marker. What formatting is used? You can pause the video here. You have seen compound labels before. The R group, the ubiquitous R group in organic chemistry, used to connote radical or residue, is one example. Another example is when authors include a bolded number or bolded number and letter immediately after the name of a compound in the text or table. Consider the following example, where 1 and 2 are the compound labels. You can see them here. After being introduced, 1 and 2 can be used instead of the compound names, thereby saving considerable space. The numbers are bolded so that they can be easily differentiated from other numbers in the text, such as citations. The authors first use compound labels in their equations to illustrate the conversion of an unspecified nitrile 1 to an unspecified tetrazole 2. In the scheme at the bottom, a label for specific tetrazoles such as 2A is introduced. This table also provides the information needed to unlock the specific structures of 1 and 2 in the author's equation 1. For example, in this table, the R group on the tetrazole is phenyl, hence R is also phenyl on the nitrile, and their equation becomes more explicit. Excerpt C does a good job of moving the reader's attention back and forth between the table and the text, highlighting important results but not repeating the data. As you can read the text, it becomes clear that the authors have organized the table not in an arbitrary way, but according to nitrile type, aromatic, electron poor aromatic, electron rich aromatic, etc. And this organization helps the reader see the trends in the data. The slide that we can see here refers to R as a variable side chain, radical, or residue, and it gives you an example. Graphics, in combination with the text, allow authors to communicate information efficiently. Graphics present, summarize, and highlight trends. They give the reader the chance to be independent. And they also include navigational signposts. Let's examine table formatting first. A general rule of thumb is to use a table only if you have enough data to fill at least 3 rows and 3 columns. Otherwise, describe the data in the text in a sentence. Also, be careful not to report the same data in both a figure and a table. This table provides a good example of a table because the table legend goes at the top. Column, horizontal, vertical lines demarcate the different sections of the table. The table main data go in the middle. After the bottom line, you can see the footnotes. the table stands alone. It can be understood without the text. Now that you have seen a good example, let's identify some formatting mistakes in the next table that you will see now. You can pause the video here before I provide the answer. As you can see, this is a much better version of the previous table because it aligns numbers on the decimal. It includes a leading zero for numbers smaller than 1, below 1. It left justifies word entries like ethanol. It uses lowercase for words in columns like ethanol, unless the word is normally capitalized as in its compound names. It uses unbolded fonts unless the entry is normally bolded. It gives every column a brief heading. In general, headings are unbolded, except for normally bolded items, as in 2A, or yield of 3. A compound label. It includes units in the headings, in parentheses, not in the values in the columns. The unit alone as a column heading is not acceptable. It formats units and symbols properly. It includes an entry column, leftmost column, to list sample numbers or trials. It includes this column only if the author refers to specific entries. It orders the entries according to their presentation in the text and numbers them sequentially, 1, 2, 3, etc. It does not use labels that were used in the work like SO101280. This means nothing. It is completely meaningless to readers. It uses footnotes when it's necessary to share information about the whole table, to explain column headings, to define abbreviations, to provide additional information. And as you can see, footnotes are referenced in the table using a superscript. And last but not least, it avoids boxes and vertical lines. So this is a good table. But despite what I've said already, you need to consult the author guidelines because there are variations from journal to journal. And I don't want to make you think that this is the only way you do this. Now, based on the guidelines given just now and following the good example we've just seen, I want you to identify at least 3 formatting mistakes in this table. Take your time now and try to identify these mistakes. You can pause the video. In journals such as the Journal of Organic Chemistry and Organic Letters, equations are often included in tables, and the equation and the table entries are linked by compound labels. What other conventions do you notice in this particular example? Take your time to write your answer and pause the video here. Figures are numbered consecutively throughout the paper and mentioned by name and number in the text preceding the figure. Although many figure types exist, by far the most common is the graph. Let's have a look at this graph and the anatomy of this figure. You can see the X and Y, the X and Y axis labels are described, providing units. You can see the key to the symbols. You can see that There are minor ticks on the x-axis to demarcate, that are not numbered, to demarcate 0.5 or the distance in between. You can see that there is a legend, and this one is at the bottom. And this one is actually so descriptive so that the graph doesn't need to be supplemented by something you need to mention in the text. This is a good sample of a figure. Why is it a good sample of a figure? We can see now. The axis labels include units. The treatment group, pH levels, is specified on x-axis. The legend is complete, which in this case requires over 3 lines just to describe the treatments used and variables measured. Error bars, 41, and group sample sizes accompany each bar, and each of these is well defined in the legend. Statistical differences in this case are indicated by lines drawn over the bars, and the statistical test and significance level are identified in the legend. Now, let's have a look at another table. In this table, there are things that I want you to consider in order to identify more formatting mistakes. Is the legend appropriately formatted or placed? Is the caption appropriately formatted or placed? Have the authors placed the independent variable on the x-axis and the dependent variable on the y-axis? Have a look and perhaps identify more mistakes. You can pause the video here. As you can see, this is a far better version because all the issues that we came across with the previous table are now corrected. But in order to have a better idea of what was really improved, let's have a look at these two examples. On the table on the left-hand side, you can see the incorrect version, and on the right-hand side, you can see the same graph, not table, graph, a figure that is basically a much better version than the first one. I want you to identify more formatting mistakes or any mistakes that were not included in the previous slide. And if you do, then we can actually say that the second graph is much better because the curves are labeled clearly at the caption. Look at the caption. You have a black square and a white square labeling the curves. This one, the second one, uses legends with 2 or more data sets. If possible, we need to make the legend part of the caption, as they have done here. The caption is at the bottom, not at the top like the first one. It doesn't choose colors, but the contrast is maximized by using black and white. So this table is definitely much better than the first one. Now, what we need to know is not just how to format tables and figures, but also when not to use them. So basically, like we mentioned earlier on, sometimes we need to use words in order to report a linear relationship between variables rather than using a graph. We need to use words to describe the results of calibration procedures rather than graphing calibration curves. If you want to say things like all calibrations were accurate to this degree. we need to use words to describe simple relative abundances rather than graphing such data in a pie or bar graph. You can see the example here. We need to use words to report spectral data that verify compound identity rather than including the spectrum. We need to use words to describe the related or similar results rather than plotting multiple sets of data that convey the same trend. For example, reaction 2 followed a decay curve like the one shown in figure 2. So all in all, when you write the results section and you format your figures and tables, you need to check the following questions. You need to proofread your work and make sure that the answer is yes, and in most of the questions that are open-ended, like do tables and figures stand alone? Yes. Let's have a look at this task now. I want you to look at the schemes and work out more formatting rules before I tell you anything. These schemes are included in the last excerpt in your Google Docs. You can pause the video before I start providing some more information now. Now, schemes are used to illustrate chemical reactions. In such cases, schemes often include arrows to denote a forward reaction, to denote resonance, equilibrium, or even electron movement. They include arrows, intermediates, transition states, reactants, and products. They also adhere to formatting expectations of author guidelines, so you need to check before you make one. When you mention a scheme in the text, you need to do so before the readers see them, before the readers encounter them. You need to pay attention to titles and structure labels. You need to label only the compounds mentioned in the text. Center the labels just below the compounds, as you can see in the previous example. You need to use a descriptor after the identifier, the number, bolded or not, but this is often optional. So let's have a quiz now and see, given the fact that formatting conventions vary, see how many of the things that you know already and of the things you've noticed can help you answer these questions right. So every compound in a scheme should have an alphanumeric label. Is that true or false? You can write your answer now. This is false because it's only for those referred in the text. The title goes above the scheme. Yes, the title goes above the scheme. Schemes should depict at least two different reactions. This depends on the author guidelines. It is customary to include reactants above the arrows in schemes. Yes, it's customary. It is very common. Most scheme titles include a brief description. Yes, indeed, for most schemes we do have a description. Scheme titles use bolded fonts. And it's also true, yes they do. And periods are included after the scheme title. No, that's not true. We don't use periods, full stops. No. Now, let's have a look at the language of the results section. First of all, we can have a look at some common phrases in the results section. I'm not going to read them for you, but what I'll do is remind you that if you want to find a whole list of very good and useful phrases for the results section, you can go to the Academic Phrase Bank website and find the section that says reporting results, and you can find a whole set that might be useful. Other common phrases here you can see in this slide. And let's move on and talk about things that you now have to avoid. According to the ACS Style Guide, you have to avoid using there is or starting sentences with there is. Have a look at this sentence and tell me, what do you notice? How can you rewrite it so that it does not include there is? You can write it down. Here is a better alternative. As you can see, there are other ways of doing that, so please don't start sentences with the phrase there is. Let's go back and see other common errors. Do not overuse the words very, interestingly, surprisingly. You can use them, but please do not overuse them. Just once is enough. You can use qualifications versus instead of quantifications. Say, for example, excellent, moderate, poor, high or low, if you want to, in the text, instead of copying and pasting the exact number. Avoid overusing the word performed. Greeks always do that, instead of other verbs that they might describe specific operations. For example, you might say performed a dilution instead of it diluted. The overuse. No, it's not. It's not about overuse. Another common error is to avoid the use of this in the beginning of a sentence. This should be used in the beginning of the sentence because if it's used with a summary word, then it helps the reader focus exactly on what you were talking about. For example, if you talk about decomposition in one sentence, in the next sentence you can start it with this decomposition denotes or whatever, and then carry on talking about that so that the reader can follow what you're talking about. Now let's have a look at some other issues which concern the use of plurals. I'm not going to go through the list, but you need to be aware that there are Latin and Greek plural types that you need to adhere to. Here are here are the most common scientific words that are being used in chemistry. Novice writers, though, often have issues with the word data. The word data is a plural word and it should be used as a plural when we write things down. The mistakes involve using data as a singular noun. And I am repeating myself. In nearly all instances, the word data is plural and should be used with a plural verb. You can see examples for what I've just said in the slide. Now let's have a look at this task and have a look at one of the most overused words of inexperienced writers, and that is the word very, surprisingly or interestingly. This is just about the word very, I think. So some scientists would argue that all instances of the word very should be eliminated from the journal because its use contributes to wordiness and minimizes objectivity. It may indicate a lack of precision on the part of the writer. So I want you to think of how you can actually rewrite the sentences in order to deal with all these issues. You can pause the video now. So in some of the sentences, you can, instead of very, you can use the word highly, or if you mean something more than very, you can say extremely. Other words you can say are considerably, significantly, substantially. And if you talk about something slow or something low, basically something negative, you can just say quite low or rather slow to have the same effect, or just omit it altogether if it's not necessary. Another suggestion is that perhaps you can use a quantification as well next to the adjective you're using. If you say that something is low without the word very, just put in brackets the quantification. Another issue that we have in chemistry writing is wordiness and using vague language. Just like we saw in the methods section in the previous online seminar, we have an excerpt here which you will need to rewrite to make it less vague and less wordy. You can pause the video here. Here is a much better version where you can see that almost half of the words mentioned were completely unnecessary in the more concise version that we have here. In the ACS style guide, you can see some alternatives to some phrases that you might not think are wordy, but unfortunately there are, and it is suggested that we don't use them as much and we should use the concise alternative instead. Let's move on to rewrite the following sentences now so that they are less wordy. Take your time. And basically, in your Google Doc, write the expression that you reckon should go. And if it's not just omitted, but it can be rewritten, as in C, for example, you can also write how else you would write it to make it more concise. You can pause the video now. Generally, we are told to avoid qualifications if we can, and prefer quantifications, because one way to keep our results section descriptive is to use precise language. By avoiding overly positive or negative words that are not particularly precise, such as excellent, very good, or poor, and using more neutral terms instead, such as high or low, you can maintain a descriptive tone in your results section. Even better, you can replace qualitative terms with more precise quantitative values, as you can see in the slide here. Before I close, I want you to spend some time to revise the following paragraph by pausing the video here. And then in the next video, you will see that I have added the points that should be addressed. For example, this sentence should not be chronological. The description of the figure is about not what they illustrate really. And the last point here is that the main message conveyed is left for the end, and that should be earlier on in the description in the results section. And in the last section, I have the revised version for you. Please spend some time before I close to have a look how this can be done in a better way. So all the issues have now been addressed. Thank you very much for attending this seminar. Have a look at the results section here. Please feel free to contact me if you need any more information about results section, if you have any questions about things that you have to do.